is a particle motion problem. And I have two graphs going on here. One is this graph here, which is the motion of a particle, that's a blue dot, and it's moving back and forth along this line, which is measured in centimeters. Now, there are no measurements here, but I'm going to put some here so we can kind of think about it. Let's pretend that these are centimeters. That would be 5 centimeters, and this would be 1, 2, 3, 4, 5, from where the particle is right now. Excuse me. I'm going to ignore the 0 right there. And the bottom one is a graph of the movement in centimeters over time in seconds. Now, the movement of centimeters over time in seconds is very similar to a graph that we might do if we were going on a road trip and we had hours. So 1, 2, 3, 4 hours and 20, 40, 60, 80. So here's 80, 60, 40, 20 miles. So, you know, we might say, well, after 1 hour, we've gone 40 miles. And after 2 hours, we've gone 60 miles. I guess we hit a lot of traffic. And after 3 hours, we've gone 80 miles. So you can kind of see this would be a miles per hour. But a difference with the particle motion from a miles per hour is that, generally speaking, when we're talking about miles per hour, our car, here's a little car, is moving in just one direction. Whereas the particle can be moving in more than one direction. The particle can be moving that way, or it can be moving that way. And we're going to look at this as being positive direction, and this as being negative direction. So this is to just kind of clear up a concept that causes some problems sometimes, which is the concept of velocity. Because velocity measures what is called displacement, as opposed to distance. So if I'm starting right here at point P, and I go 4 this way, and then I come 4 back that way, even though I've gone a total of 8, my displacement is actually 0, because I've gone 4 positive, and I've gone 4 negative. So the initial thing that we're going to be doing is going to be dealing with velocity, considering the fact that it has both positive and negative direction. So I can see from my graph that I have several different intervals that I'm going to have to deal with. I have from 0 to 1. I have from 1 to 2. I have from 2 to 3. Then I go a bigger one from 3 to 5. And then I have from 5 to 6. And I've written those right over here. I've written those as different intervals over here for us to see. I might have repeated that, but the smartboard was acting up. So in looking at question A, I'm going to first look at the interval from 0 to 1. And I can see that I've been going, the slope of my displacement to time is positive. And it went up from 0 to 2. So really what I did was I moved here from 0 to 2. So I have moved in a rightward direction. Now, from 1 to 2, well, I haven't gone at all. I've stayed in the exact same place at 2 centimeters. So for there, I have been still. From 2 to 3, 2 seconds to 3 seconds, I have gone from 2 centimeters to negative 2 centimeters. So I've gone from here, this way over here, to negative 2. So I have gone in a leftward direction. Now from 3 to 5, sorry again, I was interrupted for a second. From 3 to 5, I'm still just staying right there at negative 2, so that's going to stay right there. So again, I am still. And And then from 5 to 6, I'm going to move from -2 over here to -4. So again, I'm going in a leftward direction. Let's make a connection here with something. Look at the slope from 0 to 1. 0 to 1 is a positive slope, right? When I'm going rightward, I'm going positive. In a positive direction, my slope is positive. Here, I have a slope of 0. I'm not moving at all. My rate of change is 0. Here, I have a negative slope. If I have a negative slope, my rate of change is negative. I am going in a leftward direction. Again, here, my slope is 0. My slope is 0. I'm standing still. I'm not having any rate of change. And again, from 5 to 6, my slope is negative. I have a negative rate of change. So this is beginning to make sense in relationship between the graph of my function, or actually it's f of t, and the derivative, which is represented by the slope of the lines of the function. The slope of this function, so f prime t, is called its velocity. And velocity, as you can see, can be a positive or a 0 or a negative. I can have a negative velocity if I'm moving backwards. Let's see if I can graph f prime, if I can graph velocity. I made it a little bit small on this side, but I made the graph pretty big. So from 0 seconds to 1 second, as you can kind of see over here in the graph on the left, I have gone rise is 2, run is 1. So my slope there is a slope of 2. So I have gone, I'm sorry it's off the line a little bit, I gotta adjust the smartboard. So from at 1 second, from 0 to 1, I've gone, my graph would be at 2. That was the slope of my tangent, that is the derivative. Now, from 1 second to 2 seconds, my slope is 0. So my graph looks like that. From 2 seconds to 3 seconds, I've gone from +2 to -2. So my rise is -2, -2. My rise is -4, and that's over 1 second. So from there, my slope is -4. You see this piecewise function kind of developing here. Now from 3 to 5, again, here on the left-hand side, I was going at a rate of 0. So from 3 to 5, my derivative is 0. And from 5 to 6, I was going from -2 to -4. So that looks like it would be a slope of -2. This would be the graph of my velocity. Now, if I was going to graph my speed, speed is the absolute value of velocity. So, if I'm driving my car and I'm zooming, here's my car here, right? So here's my car, great car, here's the windshield, and I'm zooming along here at a speed, let's say I'm going 60 miles per hour. Well, if I put my car in reverse, and I start going backwards really fast at 60 miles an hour, I still consider that my speed is 60 miles an hour. They don't give me a velocity ticket, they give me a speeding ticket because they're looking at the absolute value of my velocity. They're not looking at they're looking at the speed, they're not looking at my velocity. So, the absolute value of 2 is 2, but there I was going in a positive direction. Here I was standing still, and I was standing still, that's what I was doing. But here I was going backwards at 4 units per second. Well, my speed, even though I was going backwards, was positive 4 units per second. Here again, I was still just standing still, and that didn't make any difference forward or backwards. But here again, where I was going negative 2, my speed, even though I was going in the opposite direction, was 2. So the red would represent the graph of the speed. So that's kind of an interesting way to approach the issue of speed and velocity, and that velocity is the derivative of a distance to motion function, a distance to time function, and speed is the absolute value of velocity.